Dehydration reaction. Alcohols, when treated with concentrated sulfuric acid at a temperature of 443 Kelvin, undergoes dehydration and give alkenes as products. For example, consider ethanol. When treated with concentrated sulfuric acid at 443 Kelvin, dehydration takes place, elimination of a molecule of water takes place, and ethene is thus produced. Now, if we consider a secondary alcohol, it is found that a secondary alcohol can undergo dehydration in the presence of 85% phosphoric acid and at a temperature of 440 Kelvin. Now, in the case of tertiary alcohol, it is found that the dehydration reaction can take place at a temperature of 358 Kelvin and the dehydration can be carried out using 20% phosphoric acid. Since dehydration can be easily carried out in a tertiary alcohol compared to secondary and primary, we can write the ease of dehydration of alcohols as tertiary greater than secondary greater than primary. Now let us discuss the mechanism of dehydration. Consider the alcohol as ethanol. The reaction takes place in 3 steps. The first step is formation of protonated alcohol. In this step, ethanol reacts with the proton. Here, the OH oxygen uses one of its lone pairs of electrons to bind the proton, and as a result of which protonated alcohol is formed. Second step is formation of the carbocation. The protonated alcohol eliminates a molecule of water. That is, by the breaking of the CO bond, the bond pairs of electrons get shifted to the oxygen, as a result of which water is eliminated, and that leads to the formation of carbocation. Here the carbocation formed is ethyl carbocation. Third step is elimination of a proton or removal of a proton from the carbocation. One of the CH bond of the methyl group breaks, and the electron pair, the CH electron pair gets shifted. Hydrogen is removed as a proton and we get ethene as the product. Another reaction given by alcohols is oxidation reaction. It can also be regarded as dehydrogenation reaction. Oxidation here is considered as removal of hydrogen. A primary alcohol RCH2OH on oxidation gives an aldehyde RCHO, which on further oxidation gives a carboxylic acid RCOOH. Here the carboxylic acid produced will be having the same number of carbon atoms as the primary alcohol taken. A secondary alcohol RCHOHR- on oxidation gives a ketone RCOR-. This ketone can be oxidized only under drastic conditions, or it is very difficult to oxidize a ketone, and if oxidized it gives a carboxylic acid with fewer number of carbon atoms. A primary alcohol, when oxidized using a strong oxidizing agent like acidified potassium permanganate, gives a carboxylic acid. If the oxidizing agent used is chromium trioxide or pyridinium chlorochromate, that is PCC, a primary alcohol gives aldehyde. RCH2OH, when oxidized using chromium trioxide, gives RCHO aldehyde. Now consider another alcohol, CH3CH double bond CH2OH. When this compound, that is primary alcohol, is treated with the PCC, that is pyridinium chlorochromate, the CH2OH group alone changes to CHO, and that is how we get the product. Now, if the alcohol taken is ethanol, which is a primary alcohol, ethanol when treated with chromium trioxide gives ethanol the aldehyde. The aldehyde produced is CH3CHO. Note that the CH2OH group changes to CHO, and that is how ethanol changes to ethanol. Now consider the alcohol as propan-2-ol, CH3CHOH, CH3. This is a secondary alcohol. So when this compound propan-2-ol is oxidized either using chromium trioxide or pyridinium chlorochromate, the product obtained will be ketone, and the ketone obtained in this case is propanol CH3COCH3. It is commonly called as acetone. Another reaction given by alcohols is dehydrogenation reaction, which is carried out using copper catalyst at a temperature of 573 Kelvin. A primary alcohol RCH2OH when heated with copper at a temperature of 573 Kelvin gives an aldehyde RCHO. A secondary alcohol RCHOHR- when treated with copper catalyst at 573 Kelvin undergoes dehydrogenation and gives ketone as the product. RCOR- is obtained in this case. So in both these cases, that is with primary and secondary alcohols, it is dehydrogenation reaction or removal of hydrogen which takes place. If a tertiary alcohol like tertiary butyl alcohol is heated with copper catalyst at 573 Kelvin, instead of dehydrogenation reaction, dehydration reaction will take place. That is, elimination of a molecule of water will take place, and that results in the formation of an alkene. If tertiary butyl alcohol is treated with copper catalyst at 573 Kelvin, as a result of dehydration, the product obtained will be 2-methyl propene. Now consider propan-1-ol, which is a primary alcohol. What will be the product obtained when propan-1-ol is treated with copper catalyst at 573 Kelvin? We should know that it is dehydrogenation reaction which takes place. So the product obtained will be an aldehyde propanol, since the alcohol given is a primary alcohol. So propan-1-ol undergoes dehydrogenation and gives propanol CH3CH2CHO. Consider the next equation. The given alcohol is propan-2-ol CH3CHOHCH3, which is a secondary alcohol. So when treated with copper catalyst 573 Kelvin, this compound will undergo dehydrogenation reaction and the product obtained will be a ketone, and here in this case the ketone produced is propanol, that is also called as acetone. CH3COCH3 is the product obtained.